So the question is, how does resilience testing differs from the normal testing that we do? That is the integration testing, unit testing, load stress testing, and stuff like that. And what gap does it fill that normal testing usually is not able to fill it?
So like I said, when I started as a manual QA, I was working with a mobile app team, mobile device team instead. So we had a huge lab where we had a lot of devices kept, and we used to test these applications that were deployed and all the functionalities. So what I did pick up from there and putting all of this into perspective is all of these testing that we did back then was in perfect conditions. So everything was within our control. The devices, the battery on the devices, or the network that we were in, everything was under our control. So a lot of traditional sort of testing happens in perfect conditions, which normally doesn't happen, especially in distributed systems, especially if you have moved your monoliths to a cloud native application where you have a bunch of microservices thrown here and there. Then you know that the points of failures are many and a lot of things are not within your control. So you don't have a perfect condition anymore. Also, like I said, unit tests are more about focusing on, does this function work correctly? So I gave an example about checking the validity of an email address, right? So you might have a regex and you will just see whether the response is true or false, and that's what your unit test would actually check, right? So the unit test is limited to whether this function works or not. Now, talking about integration test, this is where you integrate it with third-party applications and then see whether these two services are working correctly or not. So it could be not only third party, but it could be other services within your application as well. So whether your login service is talking correctly to a forgot password service, right? So whether that communication is working properly or not. So integration test is these essentially this, communication between services, between modules, whether it's happening or not. And then obviously you have the load test. So load test is how much traffic or how much stress your application and can handle. What if suddenly there are 100 people registering on your application, right? On your login page, trying to log in. How does your application respond? Now, while we are doing all of this, there are a lot of assumptions that we have, that the battery will be 100%, the network will be 100%, and then the user will do this, and then this will happen. So resiliency basically is what happens when the assumptions that you have made actually break. So what if the internet goes off, right? How will your application respond? What if the third party service that you're using that goes down? How does your application respond, right? If you have fallback options that you've created, how does your application or system behave and fall back to the options that you have? So essentially, it's like traditional testing assumes that the entire infra is stable. And when it comes to Kubernetes, there's a lot of instability because of a lot of point of failures that are available. It promises self-healing. So a lot of us know that the moment we deploy a deployment set and a pod is scaled, it will automatically self-heal and generate a pod for it. But we don't verify how it actually works. And that is one place where, resiliency comes into picture. So your existing tests are passing with flying colors, everything is green. But what if a node drains while a transaction is happening, right? Traditional test won't catch that. And that is where you need resiliency to come into picture.